Virchow.
Is this in the PowerPoint printout?
Yes, it's all in the PowerPoint. You have all this.
Sorry, I wouldn't know it if I read it, but I promise I'll read it.
Schneiden, Schwann, and Virchow.
Do you want me to go get that other bag of popcorn?
Sure.
Schwein, Schwarz, what is it?
I mean, it sounds like a
Sure.
chocolate factory.
Schwann.
Virchow is
And Virchow.
I knew that one. The guy's name is Rudolf Virchow
Yes, because you did that
and
one.
Theodore Schwann
Good.
Are we
and
getting all Christmas and stuff?
Matthias Schwann.
Very basic. Schneiden and
I don't think
Schwann.
those are basic names.
Schwann sounds like a swan, which is an animal. He basically came up with all animal cells. Well, all animals are made of cells. And Schleiden is the
Sorry, dude.
Can't see.
I'm putting her back.
Plants are made of cells. So what they basically did was looked at all kinds of parts, all kinds of, like what I have you trying to do on your things, showing me all kinds of pictures and cell types for plants, or all kinds of cell types for animals, and that's what our panels are supposed to be looking like, but they're not quite there. Showing that all kinds of, whatever you look at on an animal, you find cells. Whatever parts you look at on a plant, you find cells. So together, they kind of put together, we're skipping a few kingdoms, but all life is made of cells. So they kind of collaborated on that. But then they had a problem with, because in this time period,
Nicole, can I see you for a second?
Oh, is this about interclass?
Yeah.
is that why nobody's here?
No, I think she's the only one from every class.
Virchow. These guys said life is spontaneous generation, that life just spontaneously appears.
Like
Like
that
that
was
guy.
come from
They-
us.
Red Eye, right?
Yes.
Did he do the fly thing?
Well, Reddy tried to show that it wasn't, so that was the fly thing to show that, yeah, that wasn't spontaneous generation, but the idea still didn't really take hold. Scientists really fought this, was it spontaneous generation or did life come from other things? Virchow showed that cells only come from other cells.
I'm in trouble. What'd you do? Oh, nothing. Just the freshman interclass can I just got canceled. Why? Because I'm not there.
Oh well. Cells only come from other cells, that's Virchow, so he corrected the mistake in the theory that life spontaneously generated, which was just an ongoing fight at that time frame.
What did Robert Hooke do? He was the first one that C cells.
Yeah. Do we happen to know this? I mean, what they did, or do we just have to know their names?
You do need to know what they did. Oh, you already got the book one.
But this is in the PowerPoint,
It's
right?
in the PowerPoint. And it's on our
Copy that all in all.
No, this is the mirror
So if you
bag.
go look at the panel we built today, that's the panel that's mostly done. Okay, so you know your cell theory. All living things are made of cells. They're the basic unit, they're the basic building block of life, the basic unit of structure.
That song really helped.
Yep.
Although I thought it was stupid.
It is silly, but it works, and all life
Like,
comes
stop
from
being
other
a part.
cells. So the cell theory, make sure you have the three parts of the cell theory.
This one's
It's actually
bird.
written out on our panel out there. You can write it out there afterwards if you wanted to. So, and remember the
Do you
song
want
I
some
gave you?
bird popcorn?
I do.
Sorry.
All living things are made of cells. That's the first one.
Do I get the first one from the next bag too?
Yep.
Is that what I get for videotaping this thing? Thanks, bud.
Are you still videotaping?
Yeah, I don't think you should.
Cells are basic building blocks. That's the second one. They're the smallest unit of
All
life.
cells made
They can hear you.
from other cells.
Just kidding.
It doesn't matter. Even if I don't post it, I use it myself.
In other words, if you go smaller than the cell, is it still considered to be living?
No.
No. So even a mitochondria or a chloroplast, because they can't live outside of the cell, they're all considered non-living. Anything smaller than the cell is
But
non-living.
mitochondria, they think used to be bacteria.
Right. Because it has its own DNA and it has its own ribosomes and it does,
Can it reproduce on its own?
yes, they do. The cell does not make mitochondria or chloroplasts. They simply divide just like the bacteria do.
That's three.
The third
Cells
one,
are made from cells.
area with less volume. So as surface area increases, volume increases faster normally, but the ratio, as the ratio gets bigger, the diffusion is faster. You want a high ratio to increase diffusion rate. It's all about how fast materials can move in and out. And as the ratio gets smaller, diffusion slows down.
So that's what the blocks were showing us. Because the big block
At a lower ratio, so diffusion was slower. Now, in terms of size, as the cell gets bigger, diffusion slows down because the ratio gets smaller as the cell gets bigger. So it's a little confusing. The cell size is the opposite of the ratio, but the ratio and the diffusion rate are the same.
What about if surface area goes up or volume goes down?
Then you can increase the ratio and increase diffusion. Exactly. Then, difference between prokaryotes and eukaryotes. That's also being put together on the panel. So pro means no nucleus, no organelles with membranes. Pro means no, they have no nucleus, they have no organelles that have membranes around them. And this team over here, oh, did you guys already put up your little bacteria?
Yes, I did.
No, but
Because this is perfect. This is a nice little
No, it's
prokaryote.
No, I made it.
It's beautiful. And this lovely prokaryote shows us they have DNA, but there's no membrane around it. There's no nucleus. Whereas DNA in a eukaryotic cell is surrounded by a membrane. They have ribosomes. They have a cell wall and a cell membrane and cytoplasm, but that's about it. They're pretty small.
I didn't label the green thing.
You don't need to label the green thing I told you.
Oh, I know. What is
Is
it?
that your plasmid?
Yeah.
Your plasmid it shouldn't be solid. It's a circle of DNA.
Well, I'll just do a thing around it.
Yeah, you can just do like a circle around. That's why I kept saying I was going to use those glow bracelets as a plasmid.
Oh.
But it's just a circle of DNA of plasmids.
Okay.
That's the only thing you need to put in that's missing.
Is there going to be organelles? Like how we had the organelles?
Yep. And so that's why we have the clear stuff ready. Okay, we have a lot of pictures ready.
Love your
Yeah,
pictures,
it's
guys.
not up yet. Sorry.
Martha, is this for something? I'm just looking all around the store.
Did you make those posters?
No.
what's the part?
It's for, I think it's
From
for
the
Yeah.
It's okay.
Okay.
It's just student council.
You should be able to tell me what a prokaryote is. It's bacteria, right? Bacteria are prokaryotes. All other cell types are eukaryotes. Only bacteria are prokaryotes. Eukaryotes, on the other hand, have DNA. They have all the organelles we study: endoplasmic reticulum,
What about-
Golgi apparatus, lysosomes, vacuoles. Those are only in eukaryotes.
Yeah, the lysosomes aren't in plant cells, right?
No, not usually.
Wait, why does
Would
the
be
lysosome do
exceptions.
that? The
It
plant
usually
doesn't?
contains enzymes for digestion, so it's like a food vacuole. Remember how we saw the amoeba?
Yeah.
Mhm.
And it kind of is surrounded and engulfed and started digesting? That then became a lysosome,
Are
that
we
food
going to come
vacuole.
back to the organelles?
How long do you think we're going to be here for?
Hopefully not much longer.
Wait, there's 6.
I'm
What
sorry, I'm just
controls-
really in trouble.
What controls what enters and leaves the cell?
Cell
Cell
membrane.
membrane.
And you gotta remember the cell membrane is made up of two essential parts, the
Lipids and
phospholipids and the proteins. Okay? The proteins fit in so that they are, the proteins in the cell membrane, you read this in your book, they have a nonpolar middle so that it matches up with the nonpolar part of the phospholipid, and then they have polar ends so that they match up, so that they can float right through the middle. So they match the
Wait, so the thing that
phospholipids.
you drew with the tails?
Right.
My mom has a diagram of it.
Yeah. We're going to get into it a lot more with the next chapter, so we just kind of glossed it right now. The next chapter, we're really going to get into the structure. dissolves the shell. Because the
So
vinegar
you
is
don't have
acid.
egg out there?
Hmm?
You don't have an egg out there?
No. For next week, I gotta start dissolving the shell.
Wait,
It was just a reminder to myself. You're gonna
Hey.
use.
Has nothing to do with
take the
us.
shell out.
Well, not if it's raw. It'll break. I don't want it to
Will it
break.
stay in that?
It stays inside the membrane that's inside the. So it looks
Wait,
like. a
does it
little-
harden the membrane or is it
Name
just
for that.
easily
We were
broken?
asking for
I'm sorry, can we get back to the
Yeah, that's
question?
the thing.
Okay, thank you.
Will it stay together better?
Which organelles would you predict something that's very active, like a muscle cell, would have a lot of? Needs a lot of energy.
Mitochondria.
Mitochondria.
I didn't understand that question.
A cell that's very active and uses a lot of energy is going to have more mitochondria than, say, a skin cell that isn't doing a lot.
Like a muscle, you said?
Right. Does that make sense?
Mm-hmm.
So the number of organelles, depending on the cell type, can vary depending on cell type to meet its needs. So a muscle cell has a lot more mitochondria than, say, a skin cell.
Do I just do the penny right on here? Do I have to get like this?
No, you can do it right on the paper towel right there. Yep.
So based on the cell's needs, you may have more
Or less
of
of these organelles. Exactly. That's the big idea. That was a good way to say it, Zach.
Good job, Zach.
Go, Zachy.
Okay, so let's go over the organelles quickly. Which ones transport things in the cell's highway?
Endoplasm.
Endoplasm,
yeah.
So I think of ER. We need to travel the highway to get to the
Like an
ER.
ambulance.
Like an ambulance.
Do we have to now stop smooth and rough?
Smooth and rough. The only difference is rough has ribosomes on it, so it's producing. And
Smooth and rough ER.
So smooth is, it produces lipids.
And rough produces proteins.
I remember that because I think of like smooth as butter and then rough like a
Smooth
steak.
butter. Exactly.
That's what I think of. Like
That's
oil,
what I think of.
oil, and just like protein.
What does the Golgi do? I think you made a Golgi today.
Yeah, it produces
Come on, Zach, you can do it.
Vesicles? Is that the word you want?
what?
Vesicles? No? Well, that's what the bubbles are called. It's the one that blows the bubbles. The bubbles we'll learn next chapter.
Doesn't it send and package?
Yeah, it packages in sorts and ships. I call it the UPS center. It packages, sorts, and ships your materials in and out of the cell. So let's say I have a pancreas cell and my ribosomes are making lots of insulin. Well, all this insulin would go to the Golgi and it would get packaged up and then it would get put through the cell membrane to be released into the blood so that it could then carry that insulin to the other cells.
Are these going to be like multiple choice or?
Yes, these are multiple choice so far. Where are proteins made?
Oh,
Ribosomes.
Ribosomes.
Wait, but doesn't the rough ER make protein?
But it's the ribosomes on it that are making it. Golgi, ER, mitochondria, chloroplast, you know, is photosynthesis, right?
Yep.
And lysosomes are for digestion, a central vacuole store, so vacuoles usually are used for storing things like water.
Wait, what do lysosomes do?
They're like your food vacuoles in the amoeba for digesting things. They contain
How many are
enzymes.
there?
It depends on the cell.
Are they in animal cells?
Yes,
Or are they in plant cells?
Not
not usually.
Are they like all in all cells except for plant cells, or are they just in animal cells?
They definitely can be in other cells, such as a protist, like an amoeba. We saw them all over the amoeba. So they're not just animal now.
So what's the difference between them and a food vacuole?
Structure-wise, not a lot. Same thing with the starch granules and all those other things. They're all just think of them as a sandwich baggie filled with something.
So vacuoles?
So a starch, they're all basically vacuoles. And so a vacuole is just a sandwich bag. That's all it is. And if I throw something into it like starch, I now have a starch granule. If I put something in it and throw some enzymes in it to digest it, I now have a food vacuole. If I throw water into it, it's just called a vacuole for storing water. But vacuoles are just sandwich baggies that have thrown
So they
things
just
in.
store
can they
whatever.
be reused?
taken apart and the materials reused.
Yeah, but how does it get from the plastic bag to the water bottle? Go backwards.
Does it leave?
Wait,
The
the
back.
more
The
nutrients.
vacuole can leave the cell.
No, whoa.
Well,
In a little
in
bag.
a vesicle,
In a little baggie.
in a little baggie. If it's a vesicle, like say from the Golgi, then yes, we'll get into that in the next chapter, how that happens. You'll see it in the next
Wait,
chapter.
how does it get out of the plastic
That's
bag?
bad, right?
Well, it depends.
Because what if all your food just left you?
Well, it isn't just gonna leave, no, the food isn't going to do this. Just your food vacuoles aren't gonna leave, they're gonna stay in until they're digested.
Vacuoles store nutrients.
They store nutrients. That's a simple way to do it.
Isn't that what lysosomes do?
Yes.
It might,
they
isn't
store
it?
the nutrients of the food that you digested.
So I do the same thing.
Basically.
But
When you talk about,
plants have vacuoles, not lysosomes. So they do the same thing, but they just don't, they don't call it.
Then why is there a need for lysosomes?
they just
Why don't
are
we just
vacuoles
call
with
them-
enzymes in them, that's all. They're a vacuole with an enzyme in them. Think of Lysol. Lysosomes are like Lysol for cleaning up, to digest all your
Oh, that's a
stuff.
good one.
Oh, I'm sorry, man.
You don't have anything on there.
No, that doesn't matter.
Oh, sad day. Sad day.
Okay.
But my question was like, how does
What could happen?
how do they like leave
Is
the
it your
back?
tongue?
It's all good.
Oh,
When it gets digested down to little
Oh,
molecules,
okay.
they can then diffuse, just like they diffuse through the cell membrane. Because it's just like the cell membrane. So if the if you take your food, the amoeba takes its food and digests it. So you've got this little bug swimming around, slowly gets broken down into sugars and amino acids. When they get broken down to the point they're as small as a single sugar, it can now diffuse through the membrane back into the cytoplasm and go to a mitochondria for energy. Okay, so it's all about the diffusion, and that's all the next chapter.
Okay.
So that's why it's a little confusing, because we haven't gotten, you're thinking ahead, but I like the thinking.
Good job, Deb.
Guys, but now.
Yeah, whatever you need. There is only one question from the reading you did last night on the organization of cells, and that's knowing that cells, groups of cells working together make tissues. Groups of tissues working together make up organs. Groups of organs working together make up
Organ
organ systems.
Oh, groups of
From cells to tissues to organs
That
to organ systems.
specialization thing.
That's
isn't part of it.
specialization. That's the only
No.
thing that's on the test. That is
We need to
specialization.
know about.
No, I know, but there was another part where like they had to be like identical and like they're the colony things.
Oh, and
That's
when they're
not-
identical in a colony. That's
need
not
to
on
know
the
about
test. That is
colonies?
not on the test. And then what Zach was saying, how some cells have more mitochondria, that's how they start to specialize by more or less of certain kinds of organelles or changing their shape, that kind of thing. So, for example, a cell on the surface of a leaf has lots of chloroplasts. Do you think cells in the stem have lots of chloroplasts? No. And they
They're
actually
hollow.
had to, yes, some of them are hollow for transporting water, and somebody was labeling that one as a plant, it was a plant cell.
Contrary.
But I had to have them change it because I'm like, oh, there's no chloroplasts. Okay. So
What do
our
they want
so
with
is
it?
going to be, okay.
He's gonna watch this.
Can you, using the frog slide, give me examples how shape relates to function?
Uh-oh.
What do you think?
So the skin cell was more like a pattern and like a layer, a covering.
Yeah, nice thin layer, and they fit really tightly together,
Wait, so
right?
why were they thin? That was a
Because
question on the
it's a
homework.
covering. It's a thin covering. They're covering and protecting, and they fit tight like puzzle pieces. Versus a blood cell is kind of round, right? And the sperm cells, you couldn't quite see them, but they have what on them?
Flagellum.
Flagellum for movement.
Oh, really?
Yes.
Yeah.
Wait, so do we have to know about that?
Well, structure and function, you should give examples.
Wait, all three or just one?
You should be able to give me an example of structure.
But
and
why were
function.
the blood cells round? Like, what was their?
Because you need to be able to fit through the tiny capillaries, right? Otherwise you won't fit.
And then, so is that why the sperm can come out of the egg so easily?
Yes, it
Because
has a flagellum to find to get to it, exactly. hear that? You have one calculation on surface area volume ratio.
What is it?
It's just like your lab. Calculate the surface area, calculate the volume. Now put surface area.
Surface area. Is there a ratio?
Surface area, and it's for a cube, I kept it a cube, is 6s squared,
You're
right?
just gonna say here, like,
I'm gonna say you have a cell
Six
with,
sides.
that's a cube, that's this size. Calculate the surface area to volume ratio for this size.
S squared, side squared.
6s squared.
So it's 6 times side squared.
Right.
6 times side times
Side, not
Side,
is length
side,
over
S is
height.
side. So let's say my cell, let's make it simple, let's say it's 3.
Okay.
So it's 3 squared, 3 times 3 is 9.
54.
Times 6 is 54, surface area is 54.
Good girl.
Volume
Will it be
is
like-
surface cubed. 3 times 3 is 9, times 3 is 27.
37.
So do we have to do a ratio?
Side cubes, yes, and then you do the ratio.
So the question's gonna be like, what is the ratio of?
Yes.
Wait, so if the surface area to volume is 4/2, what would the ratio be?
Can I do like the
Quiz.
Wait, why would it be 2 to 1?
Okay, but it's all.
Oh, okay.
Sorry.
Sorry, I'm not as smart as you.
Okay. Oh, yeah, actually, I do it here. Yeah, that's right. You know, I
Ratios
got some
or
numbers
numbers?
to do it too. Yeah, that's a great idea. Thank you. I forgot the diagram part.
Let's go back
So
to
guys,
the
let's do
manual.
one quickly. Look at, let's say I have a 4 centimeter cube.
Do we have to do rate of diffusion?
Well, you should be able to tell me that as the ratio goes up, diffusion goes up.
I mean, if you have to calculate the rate of diffusion.
No. So, Devin, help me out here.
Oh, cute.
What is my surface area if I have a 4 centimeter cube?
So 6 times 4 squared.
6s squared equals, so we do 6 times, now remember
16.
your order,
Okay.
you do the exponent first, then you multiply. You're gonna follow your, I forget what that's called.
Order of operation,
Order of
calculus.
operations, yes.
It's really
So
not that
4 squared, yep. Thank you for doing it. So 4 times 4 is 16 times 6. So what's 16 times 6, whatever that is,
Where
that's
is
your
that?
surface area.
Well, we have like big numbers, like decimals. Like,
It's gonna be easy, don't worry about it.
'cause I like calculating my math.
And
It's
the
96.
volume- It's 96?
I think so.
That sounds about right.
Yeah, it is.
Okay, the volume then is s cubed, which is 4 cubed. 4 times 4 is 16,
Times 4 is
64.
64.
So the ratio now is 96 over 64.
Which
The
is
easiest
simplified.
way to simplify it down to 1 is just to divide the top number by the bottom number.
May I have your attention, please? Congresswoman Saga's presentation will begin in 10 minutes in the lecture hall.
Did anyone know?
Congresswoman Saga's presentation in the lecture hall will begin in 10 minutes. Thank you.
I did notice that.
So 96 divided by 64 is to be like what, like 1.5 or something?
I don't know. Can you have a decimal?
Yes, you could have.
96 divided by 6.
Well, who has a phone? 96 divided by 64.
My phone's a camera right now.
Oh my goodness.
Speed.
Okay, here we go.
Come on, you're not gonna do it.
96
She's gonna
divided by 64, what do we get?
Dang it.
We get, dang it,
It's a guy.
1.5.
1.5, that's what I thought it would be. So 1.5 to 1 is our ratio. Do you see as the cell's getting bigger, our ratio? Because we started out with like a 3 to 1 or 4, whatever it was. 6 to 1, I think was our
Wait,
ratio.
so is the ratio just the surface area
This
to
is the
volume
ratio.
simplified?
That is the ratio, yes.
Wait, so would the surface area to volume be 1.5 over 1 or 96 over 64?
This is the ratio, you gotta,
You
No,
have
I
to
know.
Simplify.
surface area over.
So I
volume.
have to simplify.
I would.
Okay. Wait, would you mark us down if we didn't simplify?
It's harder to do your comparisons.
Oh, MG,
You know,
she is going to.
I want to look at 6 to 1,
This
3
is
to 1,
John's
2
take off
to
half.
1. Yeah, you need to simplify it.
Oh, so we have to compare afterwards?
Well, because I'm going to ask you, is it greater than or less than this ratio for survival?
Oh,
So to be able to compare it, you'll need to
that's
do
not
that.
hard.
No, it's not hard.
I didn't have to learn that.
Everybody, oh,
Yeah.
one of the organelles we didn't mention was cytoskeleton from provides shape for the cell, don't forget about
And
that.
That's only for animals.
Oh, and you asked a question earlier. No, plant cells have cytoskeletons, they don't have cytoskeletons.
You don't like me?
They do?
Except for, I don't think bacteria.
It says
Actually,
on
there
my
was a
thing
part.
on the animals.
Wait,
No, they don't
do we
have
have to
cytoskeletons.
label the cytoskeleton
No.
on a
No.
diagram?
No, they
Wait,
don't.
doesn't cytoskelet help with movement?
Yes.
Where is the cytoskeleton?
And shape and movement.
And move.
What
And
is,
then the-
where is the cytoskeleton?
You can't see it unless you get a special stain. You just can't see it.
I love that notebook.
Yeah,
No.
so cute.
I put a hand out.
Like my notebook.
Yeah, I got
And
it.
nobody gets
Yeah, mine
excited
too.
about that one.
What am I
You're
doing?
the same
You're
one?
looking at
Yeah,
skeleton
but mine says Christina Rodriguez on it because I recycle.
And see all those lovely
It's
notes
so
she
fun.
has on the scientists after that?
Well, yeah, she left.
Okay, I just want to wrap this up, guys.
So
Listen.
my check.
Wait,
You know, see, it says animal cells. Provides support and movement in animal cells.
Yes.
Well, because it doesn't provide movement in it. Well, actually it does. It helps to move the chloroplast. Okay,
Well,
that should be
You
animal
should
and
have
plant
that.
also.
What about amoebas?
They have a cytoskeleton.
So was the animal, plant, and protus?
Pretty much all cells have cytoskeletons. The fluid portion of the cytoplasm is the cytosol.
Cytosol?
So don't
I
forget
know
about
that.
cytosol.
The what part?
Is that a
It doesn't
filling
include
question?
the organelles.
Is that a filling
No,
question?
it's just a reminder that cytosol does not include organelles.
Yeah, but do we have to write the word cytosol?
Oh my god. She can only tell you so much.
What is it?
What if I spell it wrong? How do you spell?
SOL. Cytosol.
No, how do you spell
It's the
phospho?
liquid part of the
Give me the
cytoplasm.
thing, I'll write it.
Isn't cytoplasm liquid?
Cytoplasm it's a gel-like liquid, but cytoplasm includes the organelles. So when I'm looking at a picture of the cell, I say this is the cytoplasm.
It's one word.
Yeah.
Phospholipids is one word.
She's not gonna mark you down.
I've been writing
If you put a
phospholipids.
space. If you put a space.
I've been
you-
writing
On our
phospholipids.
test, on our humanities test, instead of Mount Sinai, I put Mount Cyanide.
Instead of
She's
all
laughing.
dangerous.
It's like,
Instead of Yom Kippur, I put Yom Kippur, and she put it wrong.
No,
Are you
you put
serious?
Kippur.
No, I put Yom Kippur.
That's right.
It's Yom with an M.
Oh, well, you said.
Oh, I thought you put it like Y-A-W-N, like yawn.
No, because you told her you put
Yeah.
Kippur, and she said, that's like putting miss at Christmas. You left off the beginning.
I don't even remember what I put.
Anyway.
Wait, you guys got your grades back?
No, but we were talking about it when we were waiting for your slow folks to finish.
Okay.
It wasn't.
Make sure you can do a comparison, pro versus you. Make sure you can talk about your scientist,
Do we
your
have an
cell
essay?
theory. Yeah, but I told you I'm probably
Hey,
gonna
Deb,
modify
when
it
are you gonna
because
pick
of
up?
the call.
So you might just let us like take notes or something and not
Or might
Now,
you just,
3:30,
instead
my
of a
mom's
full
going
essay, just
somewhere.
like list or something, and do it quick and short. Because we want to get you out there and finish those panels.
Doesn't end technically?
It ends at 3 o'clock, but it's supposed to end at 3.
Well, we're done.
Okay. Well, I need to go there, but I don't have a ride, so I told my mom 3:30. And
Studying.
You could stay to the thing in the lecture hall.
Just take these strong gifts.
We are done.
These strong gifts.
I'll try to call my.
Just dirt, walk off the book.
I'm gonna. Not again.
You need your passcode.
Oh, wait,
Is
is
there
it
any
something
major
to do with
vocab
One
on it, or is
Direction?
it just like all the organelles?
No, it doesn't.
Your vocab is like organelles and things like that.
Yeah, you have to go on to this.
Oh, remember the two articles that you read? One was on the fixing the mitochondria, the diseases it can cause, and the other one was on that article on things cells do to increase their, to get past the surface area to volume problem. So like they hollow themselves out, you just have to be able to give me examples. So you just need to make sure you review those. Oh, there's the phone.
Hey, Papa.